Today we're going to tackle graphing an absolute value. And there are two different ways to go about tackling that task. I will teach you both of those methods today. One of them works no matter what, but you might have to do extra work. One of them is easier to find, but you got to remember more things. So there's pros and cons for each of the methods. Okay? Later on, we'll have our goal will be to I'll give you the graph. And this is going to be tomorrow. I'll give you the graph. You're going to give me the equation of the graph. Okay? So that's what's on tap for tomorrow. So the first thing that we have to talk about is we have to talk about what an absolute value function looks like in graphical form. So you've seen them before. Okay? Absolute value graphs are actually pretty easy to remember. Now it fits on the page. Okay? Absolute value graphs are actually pretty easy to remember because they make a V. V for value. Right there in the title. An absolute value graph is a V. Now, that V can be wide, really wide V, but it would still go up on both sides. It can be really skinny, really narrow. It can be a V. It can be an upside down V. I call those multipliers. So we've got V for valley. We have valleys on the board. And if I were to spin it around, now we got a mountain top. Okay? So we got both those kinds. Okay? So the first method is, and this is the method that will work every single time. But you might get stuck doing some extra work with it. Okay? But again, it'll work every single time. And that is our old friend, the T-chart method. So we can make a T-chart, and we can graph these absolute value graphs. Okay? So the first step that we're going to have is we're going to pick. First step that we're going to do is we're going to pick 5 random x values. Now, our graphs, and the graphs that you have on the pink paper here, those go from -10 to +10. Okay? And so we want to pick 5 different values in that -10 to +10 range. Okay? So we want to be all the way across our graph. What we're going to do with those 5 values is we're going to find their corresponding y values by plugging them in to the equation. So we're going to plug those 5 x values into our equation. And then that's going to give us 5 points. And so then we're going to plot those 5 points. We're going to put those 5 points on a graph, and we're going to look at it. Now, if you chose wisely, you're done. And you can draw it in. But if you didn't choose wisely, then you got to do some more work. Because what you need to see, or what you need to look at, is you need to look at the 5 points that you have, and you need to say to yourself, self, can I see the vertex? Now, you may be asking yourself, what is the vertex? Well, if I go back Come on, go back. There we go. If I go back here to this, the original function, this v, the tip right there, that is what we call the vertex. It's got a more technical term for it, but we just call it the vertex because it's kind of like the vertex in a parabola. So we got to find that point. If we can see it, we're good. If we can't see it, we got to go back up to step number 1, and we got to try and find more x values, to find more points, so we can clearly see that v. Once we have the vertex, and once we have the v clearly shown with points, then we're going to connect those 2 points with rays. We are not making x's on our graph. We are making v's. Okay? So we connect with 2 rays. We don't connect with 2 lines. We connect with 2 rays. Okay? Let's put it to work. So here is our first graph function. Okay? Y equals the absolute value of the quantity x minus 2, then plus 3. So I need 5 different x values. What do you got? Negative 8. Need 4 more. No. Negative 4. 3 more. 0. 4. 8. Okay, that's fine. Okay. Now what we've got to do is now we've got to plug those values in. Negative 8 minus 2. Absolute value. Plus 3. Do we agree with 13? Yeah. Okay. So this is 13. So I'd go to the point negative 8, and then I'd go left from the origin, I'd go left 8 and up 13. Puts me up there. Negative 4. What do we get for a y value? Negative 6. Positive 6? Which one? What do we get for a y value at negative 4? 9? Negative 4 minus 2 is negative 6. Absolute value is 6. Plus 3 is 9. Zero. We agree with 3. Changing it to what? Change it to negative 2, 5?
I was doing the math.
Okay, I got you. Got you. So 5? Okay, I like 5 better. Four. Also 5? Yeah. Eight. 9? Agree with 9? Do we have the vertex? I don't think so. So we got to add some more points in, and this is where the downfall comes. We got to add points until we find that vertex. Do we have a better idea of where the vertex is? Where, Luca? 0 and 4 between purple and orange. Okay. All right. So then we've got 2. So what is the value at 1? Four? Vertex yet? No. Okay. 2? Is that 3? Vertex yet? Yeah? Let's confirm it by doing 3. 4 again, right? Vertex.
Yeah.
Yep, now we found the vertex. Okay, so we got to find that vertex. And that's the downfall of the T-chart method, is if we would have went the wrong way, like if we would have done all of them on the negative side, we would have kept going and going and going, and we wouldn't have found the vertex. So that's why we got to spread them out just a little bit. Okay, so now we have 2 rays that are going to be drawn in. We should draw those in straight, so we should use an ID or a straight edge or a side of a ruler or a side of a folder or something like that to draw things in nice and pretty and straight. And that's it. We don't cross them. Okay? They meet at the vertex, but that's the starting point for both of those rays. Forever and ever and ever. That's why there's arrowheads at the top. Okay? Now, that method is great and all, but I like this method much better. It's higher level thinking for mathematics, but it makes it so much easier. If you buy into this method, it will make it much easier for you. So this method is the parent function, the basic, I shouldn't say the basic, every absolute value function that you have to graph will look like y equals a times the absolute value of the quantity x minus h, then plus k. Every single one of them is going to look like that. Okay? Now, this is nice because all of these things are told to you by that. Okay? So A will tell you if the graph is wide or skinny. Okay? If the graph is wide, then your A value, I'm going to use absolute value here, the absolute value of A is going to be less than 1. So you would have a fraction there less than 1. Okay? So that's either positive or negative, but it would be less than 1. If A is skinny, then that absolute value is going to be bigger than 1. So if you had like 4 there, you'd be a really skinny graph. Okay? A is also going to tell you if the graph opens up or if it opens down. So if A is negative, it's going to open down. It's going to be a mountaintop. If A is positive, that's going to make it open up. It's going to be a V. K is going to move the graph up or down. Okay? So K is going to shift that vertex off of the origin up or down. Okay? And the nice thing is with K is we think normally with K. So if it's plus 3 at the end, then you would shift your graph up 3. If it's minus 17 at the end, you would shift your graph down 17. And H is what moves our graph left or right. Okay? And so this one, though, this is where the higher level mathematical thinking comes in, because we have to think oppositely. Because of this subtraction sign right there in the formula, we have to think oppositely. So when it's positive, that means we are subtracting a negative. So that's why we think opposite. When it's subtraction, we think because it's subtracting a positive. So if it's x minus 2, that vertex would actually shift to the right, even though it's minus. In higher level math, that thinking, whenever there's something inside of a set of parentheses, or in this case, an absolute value, or something like that, we always think opposite. Okay? So the steps for graphing with this formula, or with this parent function, are actually relatively easy. The first step you're going to do is you are going to graph the vertex. The vertex is going to be given to you in the equation. Okay? It's h comma k. So we take h, and again, we think oppositely about h. Okay? And then that's going to be our x part of a vertex. K is going to be the y part of a vertex. So we graph that one single solitary point. Luca, did you have a question?
Oppositely about H.
Just about h. So if it looks like I was just saying, if it looks like x minus 2, it's actually positive 2 is your h value. And if it's x minus, or x plus 3, your h value is actually negative. Okay. Then, the nice part about this formula is that the slope of the right side is A, as it's written. So whatever A is, your A value, that's going to be the slope of the right half of your function. The slope of the left half of your function is going to be negative of whatever's written down for A. Or the opposite of A. And so we can use rise over run and plot plenty of more points. And then at the end, it's the same. we connect them with two rays again. And we use something straight. Edge of a ruler, edge of a book, edge of a folder, ID, something along those lines. Okay? So we want to graph this one using the H comma K method. So the first thing that I'm going to have to find is I'm going to have to find my vertex. What are the coordinates of my vertex? We agree with 3 comma negative 2.
No, it'd be 3 or 2.
Negative 2 comma 3 has been the tweak. Why 2 comma 3 and not negative 2 comma 3? Because we think oppositely with H. And so since H looks like negative 2 there, we got to think oppositely. So I would agree with 2 comma 3 as my vertex. What is the right side slope? We got 1. Yep, because A value is 1. So that means I'm going to go up 1 and right 1. Up 1 and right 1. Up 1 and right 1 all the way. What is the left side slope? Negative 1. So am I going to go which direction? Well, so a slope of negative 1 means I would go down 1 and right 1. Right? Do I want to do that? No. Because which way do I have to go? I got to go left and up because I want to make the V. Yep. My only 2 choices are a V or a mountaintop. It's not tipped on its side. Okay? It's not greater than or less than. It's V's and mountaintops. So we go here, here. And then we can use something straight. To draw here. Okay? No, this one works too for everything. You just got to remember, like you got to remember the opposite. You got to remember that the vertex is H comma K. Whereas the other one is just literally throw an X value at the equation and get the Y value. Yep. All right? Try that one. Use either method to graph that one. Vertex. Right side slope. Negative 1 over 4. So that's down 1 and right 4. Oops, I missed one. Counted wrong. Left side slope. Left side slope. 1/4, positive 1/4. Agree? All right, I like it. Try that one. Vertex,
3, negative.
3 comma negative 4.
Yes.
Right side slope, which way you going for over?
Right.
Left side slope,
Up, back 2.
so up 1, left 2. Looks like that.
Yeah.
Love it. Yeah. You now have enough information to complete the front side of this week's homework. The only information that you don't have is the information to do numbers 5 and 6.